All attendees are in listen-only mode.
Yes, good morning, and welcome to the Soil Advisor webinar, Emerging and Reemerging Diseases in Soybeans, brought to you by the Illinois Soybean Chaplain. I am Dan Davidson, and I will be moderating the webinar today. Just a couple of housekeeping items to start with. If you included your CCA number when you registered for this webinar, and you stay with us for the entire presentation, your number will be automatically submitted for 1C EU in pest management. If you're listening to the recording of this webinar and you will need to go to the Certified Crop Advisor website, log into your account, and apply for a self-study credit. You can ask questions during the webinar by submitting your questions using the chat feature in the dashboard on the right of your screen. Without further delay, I'd like to introduce you to today's presenter, Dr. Nathan Kleczewski with the University of Illinois. Dr. Kleczewski is a research assistant professor at the university. He conducts research and extensive activities on plant pathology issues in the state, focusing on corn, soybeans, and wheat. He received his bachelor's degree in ecology and organismal biology with a plant science emphasis from the University of Wisconsin, Oshkosh, and a PhD in plant pathology from the Ohio State University. His research interests include general pathology, crop protection, disease management, disease identification, mycology, and microbial ecology. From this point on, I'll turn it over to Dr. Kleczewski to make his presentation. Again, thank you for attending today's webinar.
Thanks, Dan, and thank you for that introduction. I'm really glad to be here today. I'm able to share some information with everybody at ISA. And just so we have an idea of what I'm going to talk about today, I'm going to kind of move through a little bit here and kind of give you an overview of what we're going to talk about. Whenever I give a talk, I like to have a little bit of information for everybody. So today I'm going to provide to you some updates on some more or less well-known diseases that impact our soybean production in Illinois and the surrounding states. But also I want to give you an introduction to some new diseases that are either in the state or likely to enter the state soon, and give you some tips and tricks on how to identify those, and also management, well, what we do know about managing these diseases. So it's going to be kind of one of those, something old, something new, a little bit of something for everybody, I hope. So thank you very much for listening today, and I will move on. The first disease or group of diseases I'd like to talk about are the Phytophthora root and stem rots. Okay, and the reason I want to talk about these is that last year, if you recall, we did have some pretty persistent heavy rains that hit many of our soybean fields in the central and northern part of the state, maybe 20 to 30 days after planting, depending on where we were at. And this resulted in some issues with seedling diseases, and there was some confusion and questions regarding Phytophthora and management and resistance and seed treatments and all these other things. So I thought it would be good to kind of revise a little bit or review a little bit about this particular disease or couple of diseases caused by Phytophthora. So when we think about Phytophthora, root and stem rot, the number one pathogen we think of is Phytophthora sojae. That's one that's the most prevalent. That's one that causes the most severe symptoms and yield losses overall. If we think about production, soybean production, we lose about 44 million bushels every year, roughly, due to Phytophthora root and stem rot. There's also a second Phytophthora now that we have in Illinois and surrounding fields called Phytophthora sansemiana. This one's a little bit different than Phytophthora sojae. So Phytophthora sojae has a narrow host range. It pretty much only is going to be infecting soybean, and it's going to be causing a root rot and stem rot. Phytophthora sansemiana is a little bit different. It causes a root rot as well, but it has a broader host range. So this one can be found on corn, on alfalfa, on ornamentals such as Douglas fir, and also weedy hosts. We have a lot more to learn about Phytophthora sansemiana and how to manage it. But when we do some of these tests to test for Phytophthora, sometimes it's difficult to tell the difference between sojae and sansemiana. So just keep that in mind as I do talk a little bit about Phytophthora and you think about what might have been going on in your fields last year. In general, these diseases are going to be favored by warm and water-saturated soils after planting. Usually when these conditions occur early in the season, that's when we see the most significant issues, but you can have infection at any time of the season. And this is kind of what you're going to see in your fields. A lot of times you'll see what we call post-emergent damping off if that those wet conditions occur early in the season, where those plants will emerge from the soil and then they'll wilt and die rapidly, as you can see in that image on the upper left. Or if the plants are a little further along in the vegetative stage, you can see those plants will begin to kind of wilt, turn yellow, and die. Later on in the season, what you can see are individual plants going down with a wilting type symptom and some additional symptoms that I'll discuss here in a second. So what you're going to be looking for earlier in the season, those yellow wilted plants, you're going to be seeing oftentimes skips in your rows where some plants will be down and other plants will be healthy. And in some of your cultivars that you're planting, if there's P. sojae there, you can actually see the canker form of this disease, where you get this brown chocolatey lesion that will extend all the way from that taproot up until the top of the plant. It can go up several nodes, and this is kind of what that looks like. So what I like to think of when I'm looking at stem canker caused by Phytophthora is that those edges typically of the lesion there tend to look a little water soaked or wet. They're not clear cut like we might have with some of our other stem canker diseases that might be caused by Diaportha, for example. And also when you look at this, it's going to extend all the way into those root systems. So it's going to go below the soil line. If you pull out these plants, oftentimes those roots are going to be more or less completely decimated. So there's not going to be much root system left when it's infected with Phytophthora. So that's what you're going to be looking for in the field. Life cycle wise, how does this organism get there and how does it cause disease? We need to realize this is an organism or organisms that will overwinter and survive in your soils several years without any soybeans there. So once you have it in a soil, it's one of those things that you kind of have to think about in terms of management. So it will overwinter as these resistant spores called O spores, which are these round spores that then will sit in the soil. And when the conditions are conducive, when it's wet and they kind of detect root exudates nearby, what ends up happening is they produce a structure called a sporangia. So we're on the upper right-hand corner here of this particular slide. And those sporangia release these small motile spores that swim in the water and actually will detect those exudates from the root and use those to find the root. And then once they find the root, they colonize, and then they move into the vascular tissue, and that's where they start to cause a root rot and then potentially a stem rot as well. The oospores then get produced within those tissues, and at the end of the season, when you harvest and that residue is put back onto the field, that's going to serve as the inoculum for the next time you plant soybeans. So this is something that's going to be soil-borne, moving through the soil. Now what we have to remember when we talk about, at least about Phytophthora sojae, is that it's a very complex pathogen, and that when we manage it, we're managing a population of genetically different organisms. And this is important when we think about selecting for resistance and the types of resistance that we have. So with Phytophthora sojae, there are many of what we call pathotypes, and what these are different individuals that cause disease on particular major resistance genes. Okay, so in soybeans for Phytophthora sojae, we have major resistant genes, and when we're selecting our cultivars, you'll see these genes listed, and there's some examples here on this table I've put together, like 1K, 1C, 3A. Those might be ones that you see fairly commonly in many of the cultivars that are available. What these are is these act like doors. And these doors, when they're closed, completely prevent specific types of P. sojae from entering the roots. Think of it that way. But they do not block other types of P. sojae from entering. So you'll have some. So if we look at our table here, this is from a survey that was conducted back in 2013 and 2014, and they sampled several different fields throughout the state of Illinois, in addition to other states. And what they found was that of the pea sojae they recovered from the fields, if you look here, 1K, for example, 50% of the individuals that they recovered from Illinois fields were able to reproduce on 1K, 60% on 1C. So that means that another 50% could reproduce on or cause disease on the soybean if 1K was the only source of resistance. So if you think about this, this is a strip taken from a seed guide. These are the different types of sources you would have there, and you could select from, like if we had 1K, for example, 50%, if you selected that and you had organisms in there, you could still have 50% of your Phytophthora able to colonize and infect. Sometimes we say when there's stacked traits that can help because you have multiple sources of resistance that can provide additional protection, but those aren't always very frequently encountered. There's also something called field tolerance, and field tolerance is what we call general resistance. It's different from these major genes in that it protects against all the different pathotypes of pea sojae, but it doesn't do so. It doesn't prevent them 100%. So what it does is it's kind of acting, I say, like a I don't know, like a bouncer at a rock concert where they hold their arms together and they keep everybody from coming on stage. Every now and then someone will squeak through and then they have to pull them off stage. That's sort of what this will do. It causes the lesions to form more slowly, infections more slow, so there isn't as much disease caused, but you still can get some disease. So it's effective against all the different pathotypes, or formerly called races, but it's not complete resistance. And the other thing we have to keep in mind with the field tolerance is it doesn't start to kick in until after those plants have emerged and started to produce true leaves. So typically after the cotyledons, that first trifolia pop out, that's when this resistance starts to kick in. And this is important if we're thinking about managing those early stages of disease when the seeds are emerging, where you get those stand losses, because that type of resistance isn't going to be effective yet, and you're going to be relying on those major genes more so to protect your plants. And those major genes are activated all the time in the tissues. So those are some differences there. Now there's a lot of different pathotypes that we have out here, and there was a large survey that was done, again, 2012, 2013. If you look at the right, these are the states that were involved in the survey. What I'm showing you here is a summary of this. This is published in Plant Disease by Ann Dorrance's group. And what we're looking at here is the complexity of all the different isolates that were recovered from all these different fields. There were 873 isolates or individuals of pea sojae that were obtained from these fields. And what we found was that 58% of the isolates, or 506 of them, were able to cause disease on 4 or more of these different major genes. So that means that they're able to cause disease on multiple genes. So in the case of where I said in the previous slide, selecting those 2 genes, there might be some individuals that could cause disease on both of those genes. So they're very complex. It's not straightforward. When we think about even within a state or within a field, we have differences in how complex our pathotypes are. So in this case, here's a study where they were looking at 5 fields in Iowa and 5 fields in Ohio, and recovering pea sojae isolates and then characterizing those for the number of pathotypes that they have. And if you look here, what you can see is that in some cases, for example, field number 4 from Iowa, there was only 1 pathotype found, and it wasn't a very complex field. So even though there were 5 isolates recovered, not very diverse. But then you have some in Ohio, for example, where you had 12 isolates, and they had 12 different pathotypes. So very, very diverse. And these are some of the things we have to think about when managing Phytophthora sojae, is that it's not as simple as we make it out to be. We can have resistance in terms of our major genes, and maybe it's not completely effective because we have a complex pathotype population within a particular field. Or perhaps we're dealing with issues of activation of some of this tolerance, field tolerance in our fields. So we have to keep that in mind when we're selecting for resistance. Another thing to keep in mind here are seed treatments for Phytophthora. Now, Phytophthora are water molds. They're actually more closely related to algae or brown algae. They're not true fungi, and because of that, we have specific active ingredients that can be used either in furrow or actually as seed treatments that are going to be effective against these particular organisms. So here's a list of some of the different types of seed treatments you might encounter. And as you can see, the two that we're really focusing in on, at least for this talk, are mefenoxam, metalaxy, and ethaboxam. And there's a third one that you're probably going to see coming up pretty soon, oxythiopypirolin, that also does pretty well against Phytophthora sojae, but unfortunately I don't have enough data on that to present on that today. So when we think about our seed treatments, there actually is some evidence that ethaboxam and metalaxy gives you different results depending on the Phytophthora that's most prevalent in your field. So if you're dealing predominantly with Phytophthora sojae, ethaboxam seems to do a better job than metalaxy. And so that's something to keep in mind. But if you do have a significant issue with Phytophthora sansimiana, and there are some fields like that in Illinois, metalaxy actually seems to do a little bit better than ethaboxam. And that's again something you just got to think about when you're managing your fields. If you have a problem with Phytophthora and you're able to send samples out and get them identified and get them screened for pathotypes, that's something that can benefit you both with your selection of your cultivar and also for your seed treatment. So when we think about managing Phytophthora sojae and sansimiana, what are some things to keep in mind, kind of big picture things? I like to say select a variety with multiple resistance genes or stacked genes if you can. Again, that's not always possible, but just kind of keep that on your list if possible. Rotating sources of resistance, so you're not always going in to your soybean fields selecting one seed. You know, try to mix it up every now and then. Go into different sources, and select a variety that's rated with good field tolerance if possible. That really helps you, especially later on in the season after those plants are emerged and producing foliage. That can prevent a lot of those severe late season infections from occurring. Because remember, those seed treatments are going to be giving you 2 or 3 weeks of protection, and after that, they're not going to be giving you any benefit. So you need to have some additional protection there. So I like to really suggest going after those cultivars or varieties that have good field tolerance. If you have some areas that are notorious for flooding, if you can improve that drainage, get some tile installed, reduce the compaction, that's going to benefit you. And again, think about seed treatments. If you have a history of the disease and you kind of know that it's going to be a benefit for you, metalaxy, mefenoxam, ethaboxam, and like I said, oxythiopypirolin, those are going to be your go-to modes of action for managing Phytophthora in your fields. Now, another disease that we have in Illinois that kind of reared its head in portions of the state last year is sudden death syndrome. This is one we're all familiar with because it can cause some pretty pronounced symptoms on our soybeans, and this is actually going to kind of move into some of the other areas I'm going to discuss later in this talk. This is caused predominantly by Fusarium virguliforme. It's a true fungus, a soil-borne fungus. And then in Michigan, in 2018, they had a report of Fusarium brasiliense, which in Brazil can cause sudden death syndrome as well. So they found this in dried beans in Michigan. And I'm curious to see if this is also something that we're going to start seeing in our soybeans as well, and what that's going to mean for sudden death syndrome in soybean production in the Midwest. That's kind of a new thing. It's characterized by a root rot, similar to Phytophthora, but also foliar and stem symptoms. And even though it's called sudden death syndrome, the death is not sudden. This is something that takes a long time to occur, but it can be very pronounced when death does occur. In terms of the disease cycle, as I mentioned, this is something that's going to start in the soil, and you're going to have some resistant spores that are going to be kind of persisting in the absence of a host for many years. When you plant your soybeans into your field, especially when the conditions are cool and wet, that's going to favor infection by Fusarium virguliforme. So what this pathogen really likes is those seedlings that are growing slow, that they're not able to produce roots very quickly, and then what it'll do is it'll grow and colonize those roots. Once it colonizes the roots, it actually ends up kind of hanging out in the lower part of that root system in the vasculature, causing a root rot. And then once the plant starts to flower and produce pods, so it gets that R1, R3 stage, if there are kind of flushes of heavy rains in that field, what it does is it triggers the fungus sometimes to produce a toxin. That toxin moves up with the water-conducting tissues, with the xylem, into the foliage. And what that is going to do is it's going to accumulate in the foliage, and that causes those foliar symptoms, or that interveinal necrosis that we see oftentimes in the foliage. That will reduce your photosynthetic area. It can cause defoliation, and then we end up with yield loss due to kind of this combination of compromised roots, stand losses early in the season, and defoliation, loss of photosynthate at the end of the season. So when we think about what are we looking at in the foliage, this is kind of an image of what that interveinal necrosis looks like at different stages. It's often going to start, or it's found in patches that are going to be in low-lying areas. When we split our stems, the lower part of our stems, what you're going to see is that the that inner vasculature is going to be kind of brownish or chocolate brown, but the center of it is going to remain healthy and white, and that's what that image is showing right there. So you take your plant, you pull it out, split that stem longitudinally, and you're going to be looking for that sort of symptom. And then the other thing, if you're lucky, this is, again, maybe 1 out of every 100 stems you'll look at, but if you go out in a field and it's wet and the plants are at the right age, you can actually see this blue growth at the base of the stem or at the soil line, and those are sporodokia, or spore-bearing structures of the Fusarium verdaliforme. And it's one of these Fusarium that's blue, so it's very characteristic for this particular fungus. So a combination of the foliar symptoms, the stalk or stem symptoms, and the outer fungal growth are going to give you kind of keys to this disease. Now let's talk a little bit about management. One thing that we can start with, or talking about, as I mentioned, planting date and variety. So this fungus, as I discussed earlier, likes it when it's cool and wet. And what I'm showing you here are some data coming from Kansas this past year. And what they did was they planted, again, here they're calling them tolerant and susceptible. Some people might call these moderately susceptible and moderately resistant. But basically what you're looking at here on your top graph is the severity of sudden death syndrome. And what that is that's a cumulative assessment. Those numbers, the higher they are, the more sudden death syndrome you have in terms of those foliar symptoms over time. And then on the bottom, you're looking at soybean yield. The green line is the tolerant or resistant cultivars, and then the bluish or purple line are your susceptible, moderately susceptible cultivars. And what we're showing here is that obviously when you're looking at the two, if you're selecting something that's moderately resistant, the amount of severity overall across your different planting dates is much lower when compared to one of those susceptible cultivars. And this is reflected in the yield. Obviously these cultivars that have the resistance do better in the presence of sudden death syndrome than those that are susceptible. But what we also want to keep in mind is when we're comparing the susceptible to the moderately resistant ones, that planting date does seem to play more of a role. So by pushing the planting date and avoiding those extremely early planting dates, what you see is you get this very steep reduction in foliar symptoms without a reduction in yield. And so this is kind of what we're thinking about in terms of if we're going into a field that has a history of SDS, and we're planting a variety or cultivar that maybe is not the most resistant for SDS, avoiding those very early planting dates can help reduce the amount of disease that you see later in the year. Now, obviously, we can't control the environment. You could get lucky and not see any disease by planting early, but we're just thinking about hedging our bets and what can we do to minimize our yield losses. One thing that we did across different states is we assessed not just the differences in our cultivar variety, but also the utility of these seed treatments for reducing SDS. And the first one I'm going to talk about is Levo. We're all familiar with this one. In this particular study, there were 10 site years. This was conducted across several states and also Canada. And what we were looking at was kind of comparing our different cultivars as well as our commercial seed treatments, either our base plus Levo, at the two different rates, so the nematode and the SDS rates. And then we're looking at yield and we're looking at disease. And across all those different years and sites, this is what it looked like in terms of the amount of disease. That's what the FDX is. Okay, so that blue, the orange bar would be the FDX. What that is the foliar disease index. Okay, so that's the amount of foliar disease that we saw on the soybeans. And as you can see here, if you compare the moderately resistant on the left with the moderately susceptible on the right, there was significantly more SDS, that's what that B indicates, than in the moderately susceptible than when we compared it to the moderately resistant. Also, at the same time, we saw that there was an increase in yield when we utilized the moderately resistant varieties compared to the moderately susceptible ones. Again, in the presence of sudden death syndrome. So we saw about 74% less sudden death syndrome with a 13% boost in yield when we just switched to a moderately resistant cultivar, comparing it to those mildly susceptible cultivars. So there's definitely a benefit there if you're dealing with this particular disease. When we look at the different seed treatments here, we're looking at the CB, that's our base, commercial base, and then the Levo at the two different rates. And we're looking at the amount of root rot in terms of a percent rating here on the top. And what you can see is when we have our commercial base, we were getting a reduction anywhere between 20 and 45% reduction in root rot by adding our Levo product at the two different rates. And this also was evident in the foliar symptoms. So we saw roughly, we could average this to be about 32, 33%, but basically we're dealing with anywhere between 28 to 40% reduction in foliar severity as well. So the Levo was having an effect not only on the foliar symptoms, but also on those root rot symptoms. We also have another study where we were looking at some of these other seed treatments, and some of these include some of those nematode protectant seed treatments that are available. A lot of information out there indicates or suggests that perhaps when you have higher levels of nematodes or soybean cyst nematode, that you can have higher indices of sudden death syndrome, and that if there are seed treatments that can offer some protection against these nematodes, perhaps they could help with sudden death syndrome as well. And so what we did is we looked at some of these different products across different states. I included these in our trials in Illinois last year, and then we were looking at some of these same ratings. Again, we're putting these in fields where there's a history of SDS, we're inoculating with Fusarium vergalliforme sometimes, and also there's soybean cyst nematodes in these fields. And we're still processing some of the data, so I'm just going to share with you what we have right now. In terms of foliar severity, these were the different products that we tested. The untreated check is right there in the middle. So we were looking at, I don't know, we'll say about 18% with our untreated check. As you can see, the Levo reducing the foliar symptoms. Levo poncho-vativo, again, relatively the same. And then we have the BioST plus Levo. Those kind of settling out, giving us the least amount of foliar severity across all the states and all the different sites that were tested. Some of these other products, though, no real difference, or actually seemed like they were maybe increasing the severity somewhat, which would indicate they're not having an effect on the SDS pathogen. What about yield? That's the important thing we're worried about, right? So if you think about the top three we had, those fortunately are also the top three that are popping out here in terms of our yield relative to our untreated check, which is averaging around 58 bushels. We were getting upwards of, we'll call this, 61 and a half. It's more than that for our Levo alone, getting over 62 up to about 65 and a half or more when we have the BioST and a Levo. So those three were kind of pushing up on the upper end in terms of our yield. But what you do have to keep in mind is these other products that are out there weren't really having any kind of impact on our yields that would be considered significant, and also weren't having any effect on our SDS. So when I'm looking at this data, that BioST seems to be having a yield impact that isn't necessarily associated with the Levo, but there's some additional data that we need to gather for this particular trial, so that we have some stronger talking points, and we'll be sharing those data with everybody here in the upcoming weeks and months. But what we can say based on the initial data is that these nematicide or SCN protectant seed treatments don't have an effect on SDS. We're not getting good indication that those are actually going to be providing any additional benefit for us. The Levo, or products that contain the Levo as a component, are still the most effective at reducing the SDS, at least the foliar symptoms. And there's also some other products that you're going to see coming out here in the upcoming, I would say, weeks to months that are going to have SDS on the label. And although we're not showing you those here in this particular slide, those look pretty good as well. So we'll share those with you in the future as those data come up, and stay tuned. So you'll have some additional tools in your tool belt to help with managing this particular disease. Best management practices, I like to go through these again. If you have a history of SDS in your field and you're going back into soybeans, you can select something that is resistant as possible for what fits your particular field and your production practices. That is going to be the easiest and best way to manage for SDS. If you're planting something susceptible particularly, or something that's maybe not rated very well for resistance, avoid planting excessively early. Try to plant on time. Avoid those cool, wet conditions. With a resistant cultivar, I think you have a little more flexibility to plant earlier. But those susceptible ones, you might be putting yourself in a position where you could see more disease and lose some additional yield. And then consider, again, in a Levo seed treatment, consider it if this is something that is an annual issue for you. You're going into a field, you're planting early, and you're going to see a potential additional benefit of that, regardless of if you're using a moderately susceptible to susceptible variety or resistant variety. So think of it as taking pieces out of the pie. The more pieces you take out, the more you're going to get full, the more yield you'll get. So that's what we're going at when we're managing SDS. Use as many of those practices as you have available to you. And you'll have other tools available in the market soon as well. I like to throw out these images. I like to say, I'm looking at this plant and I come across a picture like this on my phone and someone says, what is this? I don't know, I'm looking at this. This could be stem canker, it could be, maybe it's SDS. I'm seeing some intraveinal necrosis, some plants there. I'm just looking at the foliage, maybe it's Phytophthora. What am I dealing with here? Herbicides? I don't really know. What we're actually looking at is something called taproot decline. Taproot decline is caused by a relatively new pathogen that was just described called, or belongs to a group of fungi called Xylaria. And they're actually wood rotting fungi. And what we're seeing is that this particular disease is becoming, I don't say more prevalent, but I think we've missed it for many years in many parts of the soybean production area. And it's been mostly recognized in that mid-south area. So this is where we see it right now in Arkansas, Alabama, Louisiana, Mississippi, and Tennessee. But there's some indications, and this is based off of samples sent to our colleagues in the South, that it's likely in Missouri. They've said, look, Nate, if you look in the southern parts of Illinois, you go out by maybe the southwest part of the state, I guarantee you're going to find this out there, and you're not really aware that it's out there. You might be misdiagnosing it as something else because it's very easy to misdiagnose with other diseases. So this is a relatively new pathogen. We're learning a little bit about it, and really what I want to do is kind of build awareness about this pathogen, and let's keep our eyes open for it. And if it does come in the state, let's deal with it. So what are we looking at in terms of symptoms? We're going to see these symptoms at any time in plant growth. So this is another soil-borne pathogen that is going to be infecting those roots, and it's going to be growing into the roots, causing a root rot. and a kind of a lower stem rot. And anytime we have that happen in our soybeans, we can see issues with wilting, interveinal necrosis, plants dying, stand issues. The big thing with this disease is that the affected plants are very sporadic. So you're going to see one plant next to a plant that's maybe looking a little sick next to a healthy plant. And then the higher the incidence, the more overlapping symptoms you see. But oftentimes these are found down a row. They're not necessarily in those patches that you might see with Phytophthora or with SDS. If we split those stems, you kind of see, take the plant out, those roots are going to be gone. Split that stem, it's kind of rotted, very similar to SDS, that inner tissue kind of remaining white and healthy. But the key here is that those roots are black, and they are jet black, and there's not a lot of fine roots to them. That's kind of the key to this particular disease, these jet black roots. What you also can see, if you're lucky, again, you go out at the right time of the year, you're going to see these little finger-like projections, and these will oftentimes be on the base of the stem or on the soil surrounding the stem. And these are actually fungal structures called stromata. And when these pathogens are found on trees, if you look up xylaria, you're going to find something called dead man's fingers or devil's horns. And that's kind of the common name of this particular group of fungi. This is the soybean version of dead man's fingers or devil's horns. Must be a tiny devil or someone with very tiny fingers, but that's kind of what you're going to look at there. That is a sign of the pathogen, and that's kind of a dead ringer to know if you're dealing with this particular organism. So here again, some of those structures growing off of residue on the soil right there in the absence of having a living plant. So you can find these anytime you have residue on the soil. This is kind of a typical situation in terms of the distribution. Where on the left, you see a plant that's dying and the foliage is falling off. It's not looking good next to a plant that looks sickly next to a healthy plant. And the more disease you have down that row, the more of this sort of pattern you tend to see. What are some things that tend to favor disease? Again, I said this is a relatively new disease, so we're still learning about it. Soybean monocultures definitely seem to favor this disease because it's going to be overwintering and growing on that residue and persisting in the residue. So reduced tillage. The more residue you have and then that accumulates, that's going to be more potential pathogen in your field. And then one thing, of course, is the super accurate planting, right? So we're using RTK, we're using these methods to put our beans right back into where we placed them the previous year. What that actually can do in this case is it can place those seeds right where we have those infected roots and bits of residue, and you've basically inoculated your seeds with this pathogen. And so in the South where they do this, they say those people are at highest risk. I would say for us, this might be a situation where we might be most likely to see this disease if we have fields like this, particularly in the southern parts of the state that follow these kinds of conditions. That might be where you're going to start seeing this disease pop up first. And you can see this visually in the field. So this is an image from Terry Spurlock at Arkansas where these plants, they look yellow and sickly across this whole field. You look across this image, that field looks pretty crummy. I'd be a little concerned if I was looking at this field. I might not know what it is at first. You'd have to dig and look at the stems, but that soybean doesn't look too good at this point. Here's another image from Mississippi, and this is what it can do when it's very severe. You can see these plants going down, and there's going to be some significant yield losses there. And there is some relationship. Again, this is all very preliminary. But as there's an increase in incidence in the field, there's an increase in the percent yield loss that you see. What we do know, again, we're trying to accumulate all the data from the affected states this last year, and those data should be out soon. But at least in Louisiana, they're looking at anywhere between 700,000 to 3.5 million bushels being lost annually since they first started seeing this disease cause a problem in 2014. And that's one of the reasons why I want people to keep their eyes out for this disease, and if we do see it, let's nip it in the bud before we end up in that sort of situation. So let's keep our eyes out for this disease. In the South, they're doing some variety screening, and what they're finding is that yes, the majority of their varieties that they have in their region are very susceptible, and that's expected. Nobody's really screening for it, but there are some that are moderately susceptible, and even a few that are resistant. And I would hope that as this pathogen moves further north, we're able to get some of these data for some of our cultivars as well, so that we can start promoting those cultivars, and also breeders can start incorporating some of those traits into their cultivars going forward. Another thing people have questions about in furrow and seed treatment, again, very preliminary data coming from Trey Price down in Louisiana. But what they're showing here is, if we're looking at our non-treated check, they're getting about 50% yield reduction in the non-treated. A lot of those seed treatments aren't having any significant effect relative to that non-treated, as indicated by those A's and B's that would overlap there. But then they do have some of these treatments that do seem to be reducing the amount of yield reduction, such as Ridmel, Headline and Furrow, Top Guard Terra and Furrow, Topsin and Furrow. There's a couple seed treatments as well that I don't have in there. So there's some of this work going on, looking at some of the additional tools that we could have to manage this disease. And I would expect we'd have more of this information available if and when this disease does finally show up in Illinois. So the take home here, taproot decline in the Mid-South, it's a serious and chronic disease, and it nips their yields pretty significantly. They're very concerned about it over there. I think we need to be really thinking about this disease, especially in that south part of Illinois. It's likely that we have it here. If it's not here, it's probably going to get here sometime in the near future. It's going to be moving in on equipment and shoes and things like that. Once it establishes, it could take a few years to show up, but we need to be looking for it. It can easily be misidentified as SDS, stem canker, brown stem rot, and these other diseases. And keep it on your list of things to look for as we're scouting this year and future years. Which leads me to my last disease. Another question, what is this? In fact, that's these are the images I was given. What is this? Same sort of thing on the foliage. Plants dying, interveinal chlorosis, those green veins on the leaves, plants going down in bunches and individual plants. So then we go out to the field and we start looking at it, and we actually identified this as a fungus that causes a disease called red crown rot, which is pretty interesting if we think about it. And in this particular field that we were looking at here, this producer took about a 25 to 30% yield reduction in this field where he had red crown rot. He had about 80 to 85% incidence in that field. So it's very well established. When we looked at the base of those stems, this is what we see symptom-wise. So you see these red structures at the base or the crown of the stem. That's why it's getting this name red crown rot, because the crowns are going to be red and have these structures, particularly later in the season. R4, R5, as those plants are maturing, you're going to start seeing these red structures produced at the base. If you pull those roots out of the ground, the roots are very rotted. They're oftentimes missing those healthy white-looking feeder roots. The base of the stems oftentimes have this kind of reddish look to them. Could be misidentified as maybe a rhizoctonia or something like that in some cases, but it's this production of those red structures at the base that's really going to be the kicker. When you split those stems, the lower part, just like you do for SDS, you'll notice there's going to be a little bit of that browning in the lower part of the crown, but instead of that healthy white center pith, you're going to notice it oftentimes will have kind of a gray look to it, just in the lower part of the crown. Unlike charcoal rot, which can extend up the stem, this is going to be something that's just at the base of the stem. You also are going to see interveinal chlorosis. So similar to SDS, this is a soil-borne pathogen. It overwinters and infects the roots, causes a root rot, can impact, just like SDS, our production. But then later in the season, if there's rains and it's warm, it produces a toxin that gets wicked up into the foliage, just like our SDS, and can cause some very similar symptoms. So it's going to be overwintering as Mycosclerotia for at least 2 to 3 years in the absence of soybeans. It likes it warm and wet. If you think about production last year, we did have that period in the middle of the summer where it was warm and wet in some parts of the state, and that's where we found this disease. It has a pretty broad host range, but it's usually just legumes that are affected, lots of different types of ornamentals. But the big thing here is where we do find this disease, typically it's in the south, and also the southeast part of the United States where it's warmer, but also where there's peanut production. And in peanuts, it causes a significant or serious disease called black rot on peanuts, which makes it kind of interesting that we found it here, where we found it in Illinois, kind of the central part of the state, and actually where we have indications of it also being established are in northern parts of Illinois, and we've also seen some images. We're going to go back and hopefully collect some samples in that northeast part of Iowa as well. And so it's overwintering, and it's being found in areas that are much further north than we should be finding it. And so we're really curious as to what this is going to mean for production, and also try to get kind of going on management and what we can learn ahead of time in case this does become a problem. So in Illinois, we were able to isolate it out, prove Koch's postulates, and we had, in this case, 8 different isolates of the fungus, and we were looking at the ability for these different isolates to reduce germination. As you can see, there's some significant variation here in the amount of reduction in germination relative to an untreated control. We had up to 80% reduction in some cases, and 30% in others. But we are seeing that this can be a seedling disease as well as something that can affect our plants later on. What are some take-home messages on red crown rot management? Again, it shouldn't be here in Illinois. This is something that probably came over on some equipment or something like that and established itself and has kind of moved around. We want to look and do some surveys this year and kind of keep our eyes out for this. So if anyone sees red crown rot, we'll be taking samples, and we want to start doing some comparisons and some more research with this pathogen. Typically, we find it in the south where it's warm, where it's rotated with peanuts and soy. We do see that it's probably further north in Illinois and some of these adjacent states. I call it kind of the Bizarro SDS. For those of you that know Superman and comic books, Bizarro is the opposite of Superman, and it sort of is like that, where SDS likes to cool and wet early in the season. This is one that's going to like it warm and wet, but the symptoms are going to be very similar to SDS in many ways. If you think about a lot of the surveys we do for SDS, or when we do our diagnoses of SDS, a lot of times we're doing those window checks, right? We're driving our trucks, we're pulling up at the side of the field. Yep, intervenal chlorosis, it's probably SDS, and we kind of check it off and we move. So how much of this is being confused with SDS? Again, I'm not sure. Another reason to get out of your truck, pay attention to your plants and really get in there and dig in and look for those symptoms and signs. Management, what do we know, at least from the south? If you do have significant disease, you want to be rotating to a non-legume. So rotate, for example, the corn for at least 2 years. Avoiding excessive residue. So in cases of where you're doing conservation tillage, some disking, some light disking, sizing that residue to help with the decomposition, avoiding those heavy residue situations. And anytime you have low-lying areas or compacted areas, you have water pooling, you're probably going to see more of this, and you want to improve your drainage where possible. So with that, that's the end of my talk today. I thought I'd, like I said, talk about something old, give you some updates as well as something new. And I thank you all for attending this webinar. And I'll sit back and listen to some questions from Dan.
All right, Nathan, thank you. Thank you very much. A couple of new diseases to be able to look out for. I admit I didn't see these coming. I hadn't read anything about them yet up here in the central Corn Belt. As you start out looking at some of these seedling diseases, how do you prioritize which ones are kind of important in the kind of northern half or 2/3 of Illinois and the southern part? Because of differences in the timber soils and the more prairie soils in the north, how would you prioritize which are the most important ones to look out for?
Well, in the southern parts of the state, we're going to be obviously dealing with some of these diseases that are going to be dealing with those warmer temperatures early, and so you do tend to have a higher chance of seeing issues such as Phytophthora, for example. With the one disease I talked about, red crown rot really likes it warm. Taproot decline, obviously, that's probably going to be favoring a warm condition as well. But what we do have to realize a lot of these diseases is that we say they like it cool and warm, but it's really, it's a wider temperature range than that, and really what's causing a lot of these seedling diseases, it's going to be the wet conditions. And what I tell people when I'm talking to them, a specific grower about selecting cultivars or management practices, is really to go back to your field history and what have you seen in the last 2-3 years, and that's how I try to prioritize, because it's really hard to say, well, if you're in the South, you're always going to have this disease or that disease. I think you're more likely to deal with any of these diseases at any part of the season when you do have wet conditions. So there's no magical delineation in the state with some of these seedling diseases. It's if you're wet and what is your history.
Okay, but you just made a comment that leads to one of my questions here. How do growers assess their field risk for seedling diseases? How do they assess that where the field's really at risk?
So it's one of those things. During the season, you really can't do that. This is something that we, as pathologists and in industry too, we're working together to come up with tools that can better give growers that indication of what is risk. So we are working on some tools where you could take, say, a soil sample, and you could quantify the different pathogens in the soil, and that will give you an assessment of how much of some of these different seedling pathogens are in a given field, and that will give you a better idea of what your risk is. Without having those tools ready and available to producers, again, it has to do with your field history, and in some of these diseases, we're talking about, for example, SDS. What's the cultivar you're planting? How early are you planting? And that's all going to give you some keys in terms of your risk level if you're climbing that ladder of risk.
Okay. Here's an off-the-wall question. A lot of interest in soil health today, which it kind of boils down to increasing the microbial community in the soil and its activity. That kind of is a measure of soil health. But if we're trying to increase soil health and microbial activity, are we increasing the risk of soil-borne pathogens because they're part of that community?
Right. So, and that's a good question, Dan. And so one of the things when we talk about soil health, we talk about increasing microbial activity. What you end up doing is you got to think about pathogens. They're good at causing disease, right? But a lot of them aren't good at just being good saprophytes or growing on residue and competing with other microbes. And so when we increase our soil health, the idea is you're going to be increasing those microbes that are better at feeding off of different forms of carbon in the soil and different forms of organic nitrogen. And what they end up doing is effectively outcompeting the pathogens for space and for nutrients. And so when it does come time to, say, plant your soybeans into that field, those pathogens have a lot more other organisms that are more or less in the way, preventing them from infecting and causing disease. So that's kind of the idea behind soil health.
So that's from a soil-borne pathogen. That's actually building soil health and microbial activity. That's a benefit to suppressing some of the soil-borne pathogens.
Right, and sometimes you'll have the direct competition for nutrients, and then sometimes what you can end up having is you can have organisms that might feed off the pathogens and actually kill the pathogens, and that can happen as well when you get into these situations with improving soil health.
Okay, so there's another question. We have a conundrum here. Everybody wants to plant soybeans early in April because, I mean, the yield benefits very obvious. But yet, for SDS, the risk increases significantly.
Right.
How do we handle that? How do we handle that conundrum if growers want to plant early?
Well, the one thing I say, if you've got a history of SDS, and then in those graphs I showed, I think it showed a very good example. If you can select a more resistant cultivar, you can get away with planting a little earlier in the season, and not be at as high of risk of a high level of risk as if you're planting in a susceptible variety. If you're going in with a very susceptible variety, you are putting yourself at higher risk. And I would say, if you want to plant early with a susceptible variety, an investment in an SDS seed treatment like an Levo would probably, be something that could provide some benefit. But really, if you want to reduce your risk and get the yield benefit and have more consistent benefits, selecting those cultivars with more resistance can really help you take advantage of those early planting windows.
So you can manage through that risk by selecting resistant variety, using a seed treatment, and you could also delay planting on some of those what you might consider a high-risk field. You could delay that field.
Yes.
That would be beneficial. Okay.
Yes.
You didn't really talk anything about Pythium today, and there's a lot of biotypes of Pythium out there, and I know that's created some issues. What's the status of Pythium in Illinois and our ability to control it?
So Pythium would be a 40-minute talk by itself. So that's one of the reasons I didn't talk about that. But yeah, there's been a lot of interest in that here in the off season. Pythium, what we have to keep in mind there is that it's a complex of different species. In the past, the way we thought about Pythium was, well, this is going to be a cool season disease that comes in when it's wet and cool, right? But what we're finding now through some of the surveys and some of the research that we're doing is that it's not that simple. It's a lot more complex than that. And there's many different species of Pythium out there that can cause seedling diseases on soybeans, and they have different temperature optima. So you'll have some that'll do well under cool conditions, some that'll do well under those moderate conditions, and some at those high temperature conditions. And the big thing that is consistent across all of those organisms that is that wet weather early in the season. So what we are seeing with the Pythium, we're making some progress in terms of the seed treatments available, and there are some that will benefit, but again, what we have to keep in mind is the seed treatments are going to have a limited window of protection. They're not going to protect a plant from drowning. So if a seed is underground and it's underwater for a couple of weeks, seed treatment isn't going to really provide any benefit there. And we're also looking at some of the resistance or tolerance as well for Pythium. It's a really difficult complex to control simply because there's so much diversity out there. In Illinois, in some recent surveys that we conducted in collaboration with Dr. Maduros, in a limited number of fields, I think we had about 30 fields, but we had about 10 different species that we were able to isolate out of those fields. Oftentimes many different species in the same field, and they can vary in their aggressiveness and importance. And so, it's a challenging disease complex to work with. I think that we're going to be learning a lot more about that particular complex here in the upcoming years.
How many, when farmers buy their seed, growers buy their seed, it usually comes with some seed treatment package determined by the seed company or often by the dealer. How many active ingredients do they need to, fungicide active ingredients, do they need to have on their seed today? Is that kind of a magic number?
I wouldn't say there's a minimum number. As I did mention, though, if you're dealing with some of these oomites like Pythium and Phytophthora, and you've had issues with them before and they're a concern to you, you do have to focus on those active ingredients that have efficacy on Pythium and Phytophthora. The more you put on the seed, there's only so much you can put on a seed, so that's something you have to keep in mind as well. There are other diseases out there that can be important, like Rhizoctonia, Fusarium root rots, and different active ingredients will control against those as well. But you're looking at least having a couple different modes of action on your seed. One to protect against the true fungi, and then another if you have an issue with water molds with the Phytophthora Pythium to help you out there. So I'd say at least two different. But is there a minimum or magic number? I don't really think so. I can't really give you a solid answer on that.
So farmers, and being a small farmer myself, really have to rely on your dealers and seed companies, because it's hard. You had that slide up there of all these fungicides. As a farmer, it's very hard to keep all this straight. What you need to have, what's best. You really have to rely on your seed people to help you make that decision. So, You never talked about, I know you said it, the Pythia would be a 40-minute talk, and SDN would be the 40-minute talk
Yeah.
as well, but the SDN that's probably still the biggest yield threat in Illinois.
Yes.
Resistance seems to be breaking down. Do we have any hopes out there about how we can kind of get back some control of this organism?
You know, I think there's some really promising things on the horizon. There's some really good work coming out of Missouri and some of their soybean breeding research there, some technologies that hopefully will be adapted. This is coming from Melissa Mitchum's lab that hopefully gets adapted by industry that can help us with some of the resistance issues. And I really think that that's going to be key. I've also heard some very promising things from a couple of our industry partners in terms of being able to break some of the limitations in yield associated with some of the other sources of resistance. So one of the issues that they've come into in the past is the pecking and some of these other sources. When you do incorporate those into a cultivar, it can come with a significant yield drag or some unfavorable other characteristics, and now they're seeing that some of those characteristics can be broken, and that maybe in the next 4 or 5 years we're going to see more cultivars out here that'll have more diverse sources of resistance. That's really going to be the big key for managing soybean cyst nematode in the future, is being able to diversify what resistance genes we put in the soil. I think we're also seeing some progress in terms of the biologicals and seed treatments, but the jury's really out in terms of how effective those are and how best to use those. But at least there's some work being done in those areas, and some tools that are being developed that can help us manage soybean cyst nematode.
One last question. Being out of soybeans for 2 years. Being out of soybeans for 2 years, like a corn soybean rotation, would that really knock back these soil-borne pathogens if you're out of soybeans 2 years? Is that an effective strategy?
It all depends on what you're dealing with, to be honest with you. So let's go back to SCN, for example, soybean cyst nematode. If you have a population of soybean cyst nematode that's extremely high and it's really causing a yield loss, a single year rotation to corn can reduce your SCN populations by 50% that first year. But the benefit after you go in a second year is minimal. So really that first year was where you get the benefit. 2 years, not necessarily seeing a benefit. With SDS, conversely, we're actually seeing that when we rotate to corn and go back to soybean, it almost seems like, not doesn't seem like, but we're getting pretty good evidence that you actually have higher levels of SDS in those fields than next year you go into soybean. So it's really dependent on the organism. I think in general as a strategy, rotation usually, at least for 1 year, is going to be beneficial in terms of reducing the populations of pathogens and providing yield benefits for multiple reasons. So in general, it's a good practice, but there are cases where there's always exceptions to the rule, and I think SDS is an example of that.
Okay. Well, Dr. Kleczewski, I want to thank you very much for the great webinar today. Thank you for taking the time to present it. Again, on behalf of the Illinois Soybean Association and Illinois Advisor Soybean Manager website, we want to thank you for participating in today's webinar. This concludes our webinar on emerging and re-emerging diseases in soybeans. You will find this webinar and other soybean and agronomic resources on the checkoff-funded website, the Illinois Advisor. Thank you for attending and have a great day.